In this episode, we're diving into scalability, a crucial concept in software development. Scalability is about how well a system can handle an increase in load as it grows. Now, when we talk about scaling, it's not as simple as saying a system scales or doesn't scale. The real question is, how does it handle growth? Let's break this down. First, you need to understand the current load on your system. Load can vary depending on what your system does. For example, it might be the number of requests per second on your web server, or how many active users are on your app at any given time. A good example is Twitter, where the challenge wasn't just about handling tweets, but distributing them to all followers. Every time a user posts a tweet, Twitter needs to send that tweet to everyone who follows them. Initially, Twitter used a system where it looked up tweets in real time every time someone refreshed their homepage. This was manageable in the early days, but as more users joined and tweeted, this approach couldn't keep up. To fix this, Twitter switched to pre-building home timelines. Basically, instead of looking up tweets on demand, Twitter started to prepare and store each user's timeline in advance. This made reading timelines much faster, but it added complexity to the process of posting tweets. For example, if someone with millions of followers tweets, it means millions of updates to those timelines. So even though this change improved performance for most users, it made the process of posting a tweet much more demanding on the system. This brings us to performance. Once you know the load, you need to measure how performance changes as load increases. Two key metrics here are throughput, how much work your system can handle in a given time, and response time, or how long it takes to get a response. The tricky thing about response time is it can vary widely. You might have a lot of fast responses, but a few will take much longer. This is why we use percentiles to measure performance. For example, the 99th percentile response time shows how long the slowest 1% of requests take. These are important because they affect user experience, especially for high-value users who may have more data, like big customers or celebrities. Now let's talk about handling increased load. There are two main ways to scale: vertically and horizontally. Vertical scaling means upgrading to a more powerful machine. Horizontal scaling means adding more machines and distributing the load. For example, if your system is handling too many requests for one server, you could add more servers to share the work. However, it's not always that simple, especially when it comes to data. Scaling stateless services, like handling requests, across multiple machines is relatively easy. But when you need to scale a stateful service, like a database, things get much more complicated. That's why, for a long time, many systems kept their databases on a single, powerful machine and only scaled out when absolutely necessary. In practice, most systems use a mix of vertical and horizontal scaling. It's all about finding the right balance for your specific needs. There's no one-size-fits-all solution to scalability. Every application has different characteristics, whether it's the volume of data, the number of requests, or the complexity of operations. As systems grow, you'll likely have to rethink your architecture and adapt it to the new scale. For many startups or growing companies, it's more important to focus on building a great product and worry about scaling once the need arises. But as your system expands, you'll need to ensure it can handle the increasing load while maintaining performance. That's it for today's episode on scalability. Understanding how to scale your system is key to building high-performance applications, and I hope this gave you a good foundation. Thanks for listening, and be sure to tune in next time for more insights on building scalable software systems.